Welcome to my YouTube channel. Today I'm talking about the summary function in R. The summary function is a bit unique in that its output depends heavily on the type of R variable inputted into it. If you input a vector, you will simply get the quantile of that vector along with the mean. If you input a data frame for the numeric column, you will get the same quantiles and mean. Or if the variable categorical, you'll get the different counts at the factors level. And if you input a statistical model, you will get model parameters such as the p-value, the coefficient, the f-statistic, depending on the test. Some octal argument, the statistical model you're inputting, the number of digits you want to round to in the output, and how the quantile is calculated. This is similar to the quantile function I went over in my last video. So the default option is 7, and you can look in the R documentation and decide if that's the one you want to use, or if you want to change it to any of these other methods. Okay, so I'm going to go ahead and get started. For the vector, I'm just going to sample from a standard normal. So R norm 1000. It doesn't really matter, but we want to represent a standard normal. So I put this R vector in the summary function, and it gives me the minimum, maximum, 25th percentile, 50th percentile, and 75th percentile, along with the mean. Okay. And now I'm going to input a data frame, the iris data frame, into the summary function. The iris data frame is a built-in data frame that is often used for these types of examples. So we have 5 columns. Each of the first 4 are numeric, and you get the same type of output. The minimum, 25th percentile, the 50th percentile, the mean, the 75th percentile, and the maximum. And when you have the category, you get the counts at the different levels. So the total, particularly, and Vicinity. Okay, and now we have a very different type of R object, an output of a linear model. So I'm going to do model, and for the convenience, I'm going to go ahead and use the iris dataset. So I'm going to say SQL dot, how do I spell it right? Length. And I'm just pulling that name from right here. It's distributed as SQL dot width, and I'm going to say data equals iris. So it just run like that. And if we simply try to print this model, we're going to get not the most helpful output. We get estimate for the intercept and a estimate for the coefficient on x, or the dependent variable. Oh, I'm very sorry, that's the independent variable. Still a bit new to this being videoed thing. Okay, so if I go to the summary function, I get a lot more information out of it. And I'm actually going to go ahead and delete my console so I don't put this under the screen capture of me. Okay, so as you can see, you get a lot more output. You get the quantiles of the residual, and now you not only get estimates, but you get the estimate, the standard error, and the p-value. So the intercept is significant, while the independent variable is not significant, which is fine here, if we're just looking at an example. Multiple r squared quite low, adjusted r squared is even lower. So, and you have the F statistic and p-value. So it's fair to say steeple width is not the best indicator of steeple length, and that's totally fine. Okay, if we go back to the blog post, you'll see another example where I create a data frame and print the summary of it. Okay, and that's the end of the video. Thank you for watching.